All right, part five. We have passed the halfway point. This is the beginning of the second half. So let's jump in. A random variable. A variable that takes on a numeric value that describes outcomes of a chance process. It can be continuous or discrete. Can be either one. Expected value for a discrete random variable. Discrete means there's like a set number of outcomes. There's a finite number of outcomes. Continuous means there's an infinite number of outcomes. Um, so the formula will appear on your green sheet. But let's give an example of it. Let's say that I'm taking an exam, and for me, there's only three possibilities. I ace it, I get a B minus, or I get a D minus. Those are the only three outcomes that can happen, right? When I take a test, it's crushed it, meh, or blah, right? Let's say there's an 80% chance that I get 100. This is random too, like it's just totally random. It's not true, but we'll pretend, right? Okay, so this is a discrete random distribution, right? There's three possible outcomes. I have the probability of all of them. To find the expected value is also kind of like a weighted average. Weighted average, right? If 80% of your grade is tests and you got 100 on it, and 10% is homework and you got an 80, and 10% is projects and you got a 60, what would your grade be? You would just multiply this times this, and this times this, and this times this, and then add them together. And that's exactly what we do to find the expected value. Okay, so my expected value, I don't have a lot of room here. I'm just going to multiply 100 times 0.8. So this times the probability, and then add it to the next one. 80 times 0.1, and then I'm going to add it to the next one. 60 times 0.1. So that's going to be 80 plus 8 plus 6. I think that's going to be a 94. So 0.94 or 94 because I was in 100. Okay, not bad. I got an A in the class. All right, good stuff. Okay, the actual formula is on your green sheet here. If we go to discrete random variable x, we've got the mean right here. So expected value of x, the mean of x, the average, weighted average basically, is the sum means add together, which we did, right? We added this to this to this. So we added those three things together. The outcome times the probability. Okay, and we'll let you write here. This is the outcome times the probability of that outcome. Okay, and this means sum, means we're going to add them up. This is the expected value. Write all that on there, right? It'll be kind of like little notes that you can use, but it's really helpful. You'll get used to this. You use it a lot. All right, so let's write the formula here. Mean of x is equal to expected value of x is equal to the sum of x sub I, because I can be 1, 2, or 3 here, right? Times the probability of x sub I. So probability of x for that one. So observation 1 times probability 1 plus, right? The next one, right? That's it. Standard deviation is a little funky. We've got a formula for it. So right next to this, we've got the same thing, right? This is the mean. This mean comes from over here. Okay, so that's our expected value. But this is our outcome again. This is the probability of the outcome. All right, so if we follow the formula, let's write it here. Standard deviation of this. Standard deviation is kind of the average spread of the data. We'll talk about that more later in class. It's a very important concept. in this class, how far data is spread out. So let's go xi minus mean squared times the probability of x sub I. There we go. Okay, so what we're going to do is we're just going to take, so this sums up, so we're going to take the outcome minus the expected. So the outcome is 100 minus the expected, and we are going to put it in parentheses and square it, and then we're going to multiply by the probability. We'll multiply that by 0.8, and that's the first one. This is sum, so I'm going to do it again. I'm going to do it for the next one, right? It's going to be 80 minus 94 squared times 0.1. And I'm going to do it for the third one. So that's going to be 60 minus 94 squared times 0.1. Right? And I'm going to square root that whole big old thing. And I don't know what it equals. I never figured it out. It equals something. You could figure it out if you want. I guess I could pause and figure it out. Hold on. All right, I got it. It's 10.77 or thereabouts. So I'll change these to equal 10.77. So on average, I get 94 points with a standard deviation of 10. That's pretty big standard deviation, right? All right, here we go. Suppose you're at a carnival. One of the booths are two brown bags. In each bag, there's a $10 bill, a $5 bill, a $1 bill, and another $1 bill. You pick one bill from each of the separate bags, so you have two bills all together. If the bills are the same, then you get to keep them. Otherwise, you have to pay $5. Okay, so let X be your dollar amount from the game. All right, so if we look at it, think about it, we've got four outcomes for one bag, 10, 5, 1, 1, and then I have 10, 5, 1, 1. If they're the same, I earn that. So I could earn 20 bucks, I could earn 10 bucks. And for these, I could earn 2, 2, 2, 2. Right? Let's see. Otherwise, you have to pay $5. So if I don't win, I have to pay $5. Okay, so -5 for all of these. So it's good to kind of draw what's happening, can be kind of nice. And there we go. So what's our chances of winning? I could either win 20, 10, or $2, or I could lose 5. So those are, it says creative probability distribution. So that means X and probability of X. And my winnings could be 10 or 20 or 2 or -5. And out of 16, we've got 1 out of 16, 1 out of 16, 4 out of 16, and then this would have to be 1, 2, 3, 4, 5. Wait, 10. Is that right? 10 out of 16. Yes. Because this is 10, 14, 15, 16 out of 16. There we go. We got it. Find the probability that X is less than $2. Less than $2, but not inclusive, not inclusive. So less than 2, that's going to be just this one, right? So that's going to be 10 out of 16. Find the probability of this last line or equal to $2. Well, that will include this one. So that's going to be 14 out of 16. Cool. Oops, sorry. Keep forgetting to scroll. What is your expected value of X if you played this game many times? So the expected value is going to be 20 times 1/16. We're going to multiply down and then add across. Plus 10 times 1/16, plus 2 times 4/16, and then minus 5 times 10/16. And when you add those all together, pop it into your calculator if you want, you're going to get negative 0.75. So that's your expected value. Expected value of X equals. So that means on average, every time you play, you lose 75 cents. All right, let's find the standard deviation, right? So the expected value is this, right? So for the first one, it's going to be 20 is my first outcome minus this, so minus negative 0.75. I'm going to square that, multiply by the probability, 1/16. And then I'm going to add the next one. That's going to be 10 minus negative 0.75 squared times another 1/16, right? And then I'm going to go plus, let's see, 2 minus negative 0.75 squared times 4/16. And then I'm going to do one more plus, let's see, negative 5 minus negative 0.75 squared. And then that's going to be times 10/16. And then I got it. Yay. Oops. Jeez. I keep forgetting to scroll down. I apologize. Once I have all that, I'm going to square root it, and that's going to give me the standard deviation. I think it's about $6. I can't remember exactly. That's a 16. It's about $6, right? So on average, we're losing every time. This is how casinos work, people. You lose a little bit each time, but the standard deviation is so big that sometimes you win, sometimes you lose, and you think you can gain it back, right? That's how they get you. That's how they get you. So in the long run, bad idea to be gambling. Um, in the long run, it's better to own the casino than to play in a casino. So just so you know. All right, here we go. Uh, here's the density curve. This is continuous random variable. So continuous means it's not just 1, 2, 3, 4, 5. It's 1.111111395. It's pi, right? It's every number in between 1 and 5 is in this distribution. So we want to find the probability that x equals 2. Well, the probability of x equals 2 is going to be the probability of, it's going to be length times width, right? And this would be the probability of a line. So is equal to length times width. The length is 0.5, but the width is 0. So the probability is 0. So probability of a line is equal to 0, right? Find the probability that x is less than 2. Well, that would be less than 2. So I'm going to kind of fill that in. What kind of shape do we have here? Oh, that's a triangle. So less than 2 is going to be, let's see, the triangle, and it's 1 by 0.5. So 1/2 base times height. So that's going to be 0.25, and that's square units. And it's going to be for both, right? It's going to be for both because the probability of a line is equal to 0. It doesn't matter if I include the 2 or not the 2, right? We go up to 1.9999999999999999999999999999999999999999999999999999999999999999999999999 for this one. If we go to 2 for this one, that's not very much more to add, right? Because we're already at 1.9999999, right? So for continuous variables, it doesn't matter. Did it matter here for discrete variables? Yes, it does matter for discrete variables, but not for continuous. All right, that's it. We're going to skip this problem right here. We're going to do this problem right here. Probably that t equals 0. Okay, so again, this is additional practice. Feel free to stop, come back later, whatever. I'm just going to give you the answers here real quickly. So this is area equals 1. So the area of this has to equal 1. All of these have to add up to 1. So probability of 2 is going to have to be 0.3. Okay. Yes, good. Calculate the probability of random customer purchases at most 3 tickets, at most 3. So that would be 3 or less. So that'd be 0.1 plus 0.3 plus 0.2, which is 0.6, 0.6. Expected value is going to end up being 2.9 multiplied down and add across. Again, show your work, right? 0.1 times 1 plus 2 times 0.3 plus blah, blah, blah. The standard deviation, I think, ends up being 1.04 tickets. Again, word problem, word answer. So 2.9 tickets on average with a standard deviation of 1. So it means most people come up and buy somewhere between basically 2 and 4 tickets, which should make sense, right? With this, most of the people are in this range. That's what standard deviation gives us, an idea of the range. And that's that. Cool, 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 cool. All right, people, that's it. On to part 6 next. We're almost there. Good work.